Hey guys, I had a student send me this particular question. I am not sure which homework assignment this question was in. I'm assuming this was in our just-in-time review section, where we just kind of review different objectives, um, before we actually begin chapter one. But in this particular homework assignment, the student said that, they understood what was going on with the multiply and simplify steps here. So what we had were two rational expressions that we were multiplying. And remember, when you multiply rational expressions, you multiply the top, um, the numerators together, and this is what we had. And then we multiplied the denominators together, and that's what we had. And literally what they did is they just kind of put things together in parentheses, and they didn't really distribute anything. So let me just kind of address that. So why didn't we distribute anything? Well, in algebra, we like to factor things. If we can factor them, then we do that. Um, and in this particular case, we have a binomial times a trinomial. There's no point in doing your distributive property and then factoring it back out if we want it factored. The easiest thing for us to do is just to leave it in parentheses in factored form. So that's what they did there. They left the numerator and the denominator in factored form. But what happened, or once we kind of put everything together, what I notice is in your denominator, what I circled in yellow, that is what we call, let's see if I can put this in blue. I need a small pen. This is what we call a difference of squares. And that's called difference of squares because the difference comes from the minus. The squares comes from those perfect squares. W squared is a perfect square, and z squared is a perfect square. So let's come over to the side. If you don't have this already, which should be somewhere written down if you don't have it already, the way that you factor a difference of squares is anything written in this form where a and b are perfect squares. The way you factor those is by taking the square root of your first term. Well, the square root of a squared is equal to a, right? Okay. The square root of my second term, in this case, b squared, is b, okay? So we would put b second. And then because this is minus a difference, one will be plus and one will be minus. That is a pattern that we follow every single time we want to factor a difference of squares. Now, if you follow what they did, I'm going to circle this. This is what they factored right here. The square root of w squared was w. The square root of z squared was z. And then they had their plus and their minus sign. It doesn't matter which sign you put first, the plus or the minus. Um, so they factored that in yellow. Then the w squared plus wz plus z squared, they just brought that over. Now, let's pick a different color here. Now what I notice again is I have at w cubed minus z cubed. Now that is something different there. That is not a difference of squares. That is what we call a difference. Can you guess what this one's going to be? Difference of cubes. Um, and we actually have what we call sum and difference of cubes. But let me give you the little pattern. These are patterns, guys, that I'm giving you, just patterns. If you can write this pattern down, you will always have what you need to factor a difference of squares. Now, difference of cubes, I can only factor when I have a difference of cubes, meaning something in this form. When I factor them, I like to use what I call soap. We're going to factor using soap. And let me wait before I spill out my soap because I don't want to put my letters in the wrong spot. But when I factor, guys, this is just rote memorization. I'm just being honest. This is one of those things that I had to remember when I first learned to factor. Anytime you factor a sum, I'm gonna put sum or difference of cubes. It honestly goes hand in hand. They work together. If you can do one, then you can do the other. Okay, your coefficients and your variables will be the same for both of these cases here. What you do is you look at your terms here. Okay, you take the cubed root of that first term and you put there. Then you take the cubed root of the second term and you put that there. Then you square your first term. Then you multiply, you're going to have a 2ab, so you're going to multiply 2 times the cubed root of the first term times the cubed root of the second term, and then my last coefficient is going to be that last term squared. And oops, I forgot to put a square up there. Guys, the coefficients will be the same for both of these. It's just a pattern. But now the difference here are the signs, and that's where I use SOAP. SOAP. The S stands for same. Oops, give me a minute. Same. When I say same, that means whatever sign. I forgot which one I was doing here. Same means whatever sign you had here. For in this case, I'm doing a difference of cubes. Difference means minus. Because I have a minus there, I'm going to put a minus here. Opposite means I'm going to do the opposite sign of what I had because I'm doing I am factoring. I apologize. I don't know what's going on with my screen. My computer's acting up because I am factoring the opposite the difference of cubes. That means subtraction, and the opposite sign is going to be plus. And then always positive is what the AP means at the end. So if I spell this out, that means same, opposite, and that one means always positive. So let's try it for the sum of cubes. Same sign, because the sum is going to be plus. Opposite, the opposite of adding is subtraction. And always positive means minus. Okay, so why did I go through all of that? Well, this right here is what this example utilized to factor this second piece. Let's change my highlighter. So I'm going to highlight this in, let's say, light blue. So the second parentheses here, they used our little soap no, not the second one. This first parentheses here, they utilized soap. So if I come to the side, I have a lot going on here, but I'm trying to get you to understand what happened. So the question was, what happened to this 2 right here? So I'm just trying to show you that the 2 didn't disappear, that they actually factored and things just look completely different. So they factored the w cubed minus z cubed. That was a difference of cubes. So the cubed root of my first term, you need to figure out what your a is. Your a is always the cubed root of that first term. In this case, it's w. My b is going to be the cubed root of that second term, which in this case is z. So if you can figure out what your a and your b is, you can just follow the pattern that I gave you. So it's going to be a, in this case, which is w, minus z, okay, which was my a, minus my b, right? That's what I had. And then my pattern that I have right over here was that a squared plus 2ab plus b squared. So let's just substitute my w and my z. So that's going to be w squared plus 2wz. Let's erase this. I have a little bit of room left. Plus z squared. So that is where this w minus z plus w squared plus wz plus z squared came from, which is what I have highlighted in blue. Okay. Now the last piece, I'm going to erase some of this. Um, you can always pause and back up if I'm erasing something that you need. But this last little piece here, so where does that come from? That comes from factoring this right here. So they are factoring a trinomial in this case. So I have w squared plus 2wz plus z squared. Guys, I have two variables here. And just from practice and what I know is that because this is a binomial, a trinomial, that I can factor it into two sets of parentheses such as this. And because I have this W here and I have a W and kind of no W at the end, my W's are in descending order, that I know I'm going to have a W as a variable first in my parentheses. And my Z's, they are in ascending order. I don't have a z, in that first term, there is a z to the first power, then there is a z squared. So what that tells me is that I'm going to have a z, in my parentheses also, but it's going to be that second term. So here's how, if you remember, let's go back to, I don't know how long it's been since you guys have been maybe in high school or since you've had an algebra class before this one. But when you factor a trinomial, when your a is equal to 1, that means that coefficient out front. You guys realize we really have 1 w squared, right? But because we're adults, we don't write that 1 there, right? It's there, but we just don't write it. But when your a is equal to 1, the way we factor these trinomials is by asking ourselves, what two numbers will multiply to give me the coefficient in front of my z squared. So I need it to multiply to give me 1, but I have to add to get me 2. So what number will multiply to give me 1, a positive 1 at that, because that's a plus z squared, but add to give me 2. So what you would do is you would take the factors of this coefficient of this z squared. Well, what numbers will multiply to give you 1? 1 times 1. Well, what do I know about 1 plus 1? 1 plus 1 equals what? 2. Guys, so there's my terms. So what that tells me is that my coefficients for my z's are going to be 1. So guys, once again, because we're adults, we don't really like to write that 1, so we're just going to leave it as a z. And because everything's positive here, my signs are going to be positive. And I kind of went very slow and I broke down everything, but that's where this green part came from, guys. And I hope that wasn't too confusing. But if I really need to break this down and really work this out from the first step, I can. But I was just trying to give you a little quick overview because the question was, what happened to this too? Oops, my highlighter. I apologize. My computer is not working with me tonight. The question was, what happened to that too? I guess I think it was a guy that sent me an email, maybe looked over here and said the 2 disappeared. But what happened is we factored a difference of cubes, and we ended up with all of this. And then we factored this trinomial, which gave me these 2 pieces. So the 2 didn't really disappear. We just kind of factored each one of those, and the denominator just looked completely different. And I just want to add, I don't think this problem